Okay, let's give you guys some practice now. So here you've got two vectors. This is your first vector, this is your second vector. Work out the angle between them. So for this vector, it would be 1 across, 2 in the negative direction, 1, 2, and then 2 down, 1, 2. So your vector would be from the origin to here, and then your second vector would be 6 across, 1, 2, 3, 4, 5, 6, and then 3 across, 1, 2, 3, and then 2 up, 1, 2. So from the origin, it will be straight across here. So this will be your vector v. This one here is u. Work out the angle that exists between them. So work out theta. So here's a clue. So press pause and have a go. Okay, so to do this, we need to work out the dot product. So remember the dot product, which we've already seen, it will be the number 1 times 6, that will be 6. This times this, so that would be negative 6. And then this times this, you put a negative here, so it would be negative 4. So the dot product will be the number 4. So later we can put this into here. And then we need to work out the magnitude of the vector v. So the magnitude of the vector v would be hang on, let me think. So v is here. The magnitude would be this squared, which would be this squared, and then this squared, and then square root the whole thing. That would be 7. And then we need to work out the magnitude of the vector u. So the magnitude of u would be 1 squared, negative 2 squared, and then negative 2 squared, and then square root the whole thing. That would then give you 3. So we can put this into the u. We can put the 7 into the v. So this whole thing here will then become this. So now we want to know the angle. So this thing here becomes this. Now we want to know the angle. So inverse cos will then give you this in radians. Okay. You can use degrees if you want. So next question. So this formula works even if you're in 2D. So it will still work. Well, anyway, you've got 3 points: A, B, C. So somehow work out this angle here. So your first task is to work out. Your first task is to center yourself here, and then work out this vector. So this would be your vector. This would be one vector. The other vector would be from C to B. So you're moving in this direction. So you've got to extract this vector and then extract this vector. Well, do whatever you want. Work out this angle here. So press pause and have a go. Okay. So to do this, we need to extract this vector here. So let's just call this vector here. Let's just call this vector here v. So v here. So v would be 5 across, negative 5 across, 1, 2, 3, 4, 5, and then 2 down, 1, 2. So our vector v here is this thing here, and then the vector u. Remember, you're centered here. So u would be negative 2, 1, 2, and then 3 up, 1, 2, 3. So 2, negative 2, and 3. So we are saying that the vector v here is this is u here. Now blindly follow this formula. To work out the angle, we need the dot product. So now work out the dot product. The dot product will be when it comes to the dot product, it doesn't matter if you have v dot u, u dot v, or v dot u. If you think about it, it would be. Remember, the dot product is defined as this times this. So it doesn't matter if you switch them around. It doesn't matter if it's v dot u or u dot v, because if you look at the definition, this times this, it doesn't matter if you switch them around. Well, anyway, the dot product will be this times this, which will be 10, and then this times this, that will be negative 6. So the dot product is 4. So later on we can put this into here. So that's the dot product in 2D. And then we need to work out the magnitude of v. So this is v here. We need to work out the magnitude of this. Magnitude would be this squared, and then this squared, and then square root the whole thing, so that would be this. And then we need to work out the magnitude of u. Magnitude of u would be 4 and then 9 square rooted. That would then give us this. So now we can put this into here, put this into here, and then put 13 into here. Then this whole thing here will then become this. Jump to a calculator, that will then give you this. Inverse it, that will then give you this. So this is your final answer, approximately.